Welcome back to the channel, 58 AI Bytes. Today, Docker, the technology that changed how every piece of software on Earth gets shipped. If you've ever heard, "It works on my machine," Docker is the cure. In this complete Zero to Hero episode, you'll learn what containers actually are, how to write Docker files like recipes, how layers and caching make builds fast, how Compose runs entire stacks with one command, and why. Even in the age of Kubernetes and AI, Docker skills are on practically every backend, DevOps, and machine learning job description. Real commands, real examples, zero fluff. Let's containerize something. Here's the map for this episode. We start with the problem. Why works on my machine broke production for decades. Then what a container actually is, and why it starts in seconds while virtual machines take minutes. You'll learn images and registries. Build once, run anywhere. Then the heart of the episode, Dockerfiles, writing them like recipes, understanding layers and caching, and multi-stage builds that shrink images by 90%. We'll cover volumes for data that survives restarts, networking so containers can talk, and Docker Compose to run a whole application stack with one command. Finally, the production path from laptop to Kubernetes and why AI workloads made Docker skills even hotter. Screenshot the map. Let's go. Let me tell you the horror story that created Docker. Priya builds a coupon feature for Quick Bytes on her laptop. Python 3.12, library version 2.1. Works perfectly. It moves to the QA server, which runs Python 3.9 and an older library. 3 tests fail. Weird, she says, works on my machine. It finally reaches production, a different operating system missing one system package, and crashes on Friday at 7 p.m., right at peak dinner orders. The next 4 hours are 3 teams asking each other, "What version do you have?" Sound familiar? The root cause is simple. We shipped the app without its environment. Docker's fix is equally simple and completely radical. Ship the application and its entire environment together as one sealed, portable unit. That unit is the container. Is Docker still worth learning in 2026? Let's look at the evidence. Over 20 million developers use it, with billions of image pulls from Docker Hub every month. Containers are the #1 packaging format, not a way to ship software, but the way software ships to cloud, CI, and Kubernetes. And Docker sits in the top 5 skills on job postings for backend, DevOps, SRE, and machine learning roles. But understand the deeper logic. Kubernetes didn't replace Docker. Kubernetes runs containers, and something has to build them. Those are Docker skills. Every CI pipeline executes its steps inside containers. Microservices, 50 services with 50 different dependency sets, can only coexist because each is containerized. And AI made Docker hotter, not obsolete. Models, GPU drivers, and CUDA versions are a compatibility nightmare that only containers tame. Docker isn't legacy. It's the foundation everything else stands on. So what is a container, technically? The comparison with virtual machines makes it click. A VM ships an entire guest operating system, gigabytes on disk, minutes to boot, sitting on a hypervisor. A container skips all of that. It shares the host's kernel and packages only your app plus its libraries. That one trick changes everything. Size. A Python app container can be 50 megabytes. The equivalent VM is 5 gigabytes or more. Speed. Containers start in about a second, so you can scale from 3 to 300 instances during a traffic spike. Density. One server that fits 10 VMs can run hundreds of containers. One honest caveat. VMs still isolate harder at the hardware level, which is why banks run containers inside VMs, layers of both. But for packaging and shipping software, containers won decisively. 6 words unlock all of Docker. An image is the frozen result of your recipe, a read-only template containing your app and every dependency it needs. A container is a running instance of that image, and you can start 1 or 100 identical containers from the same image. If you know programming, image is the class, container is the object. The Docker file is the recipe, a plain text file describing how to build the image step by step. A registry is the app store for images. Docker Hub is the public one. Companies run private ones like GitHub Container Registry or AWS ECR. A volume is persistent storage that survives container restarts, essential for databases. And a network is the private wiring that lets containers find each other by name. 6 words. Everything else is combinations. Hands on keyboard, 3 commands. First, Docker run hello world. Docker looks for the image locally, doesn't find it, pulls it from Docker Hub, and runs it. That message confirms your whole setup works. Second, something real. Docker run -d-p8080:18 jinx. -d means detached. It runs in the background. -p maps port 8080 on your machine to port 80 inside the container. Open localhost 8080. A production-grade web server is running, and you never installed Nginx. Third, look around with Docker PS to list running containers, Docker logs to see output, then Docker stop and Docker RM to clean up. And here's the magic. After removal, your machine is exactly as it was. No leftover files, no version conflicts. That cleanliness is why developers fall in love with Docker. The Dockerfile is where you go from Docker user to Docker engineer. So let's read a production quality one line by line. From node 20 Alpine, start from a slim base. Alpine variants are around 5 megabytes, and always pin a version. Latest is a gamble that breaks builds months later. Workter sets your directory inside the image. Now the clever part. We copy package JSON first and run npm CI, then copy the rest of the code separately. Why? Caching. Dependencies change rarely. Code changes constantly. This order means rebuild skip the slow install step entirely. env sets configuration, expose documents the port. User node is one line that stops your app running as root, a big security win. And cmd versus run. Run executes while building the image. CMD is what runs when the container starts. Ever wonder why the first Docker build takes 3 minutes and the second takes 2 seconds? Layers. Every instruction in your Docker file, from, copy, run, creates one immutable layer, and an image is just the stack of them. When you rebuild, Docker checks each layer, unchanged, reuse it from cache. Only the layers below your first change actually rerun. Look at the stack on screen. Change one line of code, and only the copy code, layer, and everything after it rebuilds. The expensive npm install stays cached. That's why we ordered the Dockerfile the way we did on the last slide. Bonus: layers are shared across images. 10 images based on node 20 Alpine store that base exactly once on disk. Understand layers and you understand why Docker is fast and how to keep it fast. Here's the pro move that separates hobby Docker files from production ones: multi-stage builds. The problem: building an app needs compilers, dev dependencies, the whole tool chain, but running it doesn't. A naive image ships all of it. 1.2 gigabytes of stuff attackers can exploit and networks must transfer. The solution is 2 stages in one Docker file. Stage 1, the workshop, a full node image that installs everything and compiles your app. Stage 2, the showroom, start fresh from a tiny Nginx Alpine image and copy across only the built output. That one copy -- from builder line is the bridge. Everything else is left behind. Result: 95 megabytes instead of 1.2 gigabytes, 92% less attack surface, faster pulls, faster deploys. Same technique works for Go, Java, Python. Build big, ship small. Critical concept: containers are disposable, cattle, not pets. Stop one, crash one, rebuild one. Anything written inside its file system dies with it. Great for cleanliness, catastrophic for a database. Volumes solve this. Storage managed by Docker that lives outside the container and gets attached at whatever path you choose. Watch the example. We create a volume called data and mount it where Postgres keeps its data files. Now the container and the data have separate lives. Upgrade the container from Postgres 16 to 17, and your data simply carries over. The second flavor is the bind mount. Map a folder from your machine into the container. That's the developer trick. Edit code locally in VS Code, and it runs instantly inside the container. Rule of thumb: volumes for data, bind mounts for development. Real applications are conversations. An API talks to a database, a cache, a queue. Docker networking makes those conversations clean. Create a network called Kubernetes. Then start containers with -- network Kubernetes and a name. Here's the beautiful part. On a shared network, names become addresses. The API connects to Postgres://db, just the word DB, and Docker's built-in DNS resolves it to the right container. No IP addresses, no config files full of hard-coded hosts. Notice the security posture too. Only the API publishes a port to the outside world. The database is reachable exclusively from inside the network. And the same model, services finding each other by name, is exactly how Docker Compose and Kubernetes work. Learn it once here, and it scales up with your career. Running containers one by one gets old fast. Docker Compose fixes that. Describe your whole stack in one YAML file. Run it with one command. Look at the file, 3 services. Our API built from the local Dockerfile, Postgres with a volume for data, and Redis for caching. Depends on control startup order. Now type Docker Compose up, and the API, database, and cache all start. Network together, finding each other by name. This file is transformative for teams. A new developer joins? Clone the repo, compose up, productive in 5 minutes, instead of 2 days of environment setup wiki pages. Done experimenting? Compose -v removes everything, leaving your machine spotless. If Docker has a killer feature for daily development, Compose is it. Let's prove the power with a challenge. A complete WordPress website, PHP application plus MySQL database, live in 60 seconds. The Compose file has 2 services. WordPress, with its port published and environment variables pointing at the database by name, and MySQL 8, with a volume so blog posts survive restarts. Start the timer, Docker Compose up. Both images download in parallel. The network appears automatically, and at about 45 seconds, localhost 8080 is serving the WordPress installer. Notice what didn't happen. You didn't install PHP, MySQL, or Apache. Your laptop is untouched. And this exact pattern runs almost anything. Swap the images, and you've got Grafana dashboards, a GitLab server, an N8N automation hub. The entire self-hosting world is 2 service Compose files away. You've built an image on your laptop. How does it reach the server? Registries, the app stores of the container world. The flow is build, tag, push, pull, run. You build the image, tag it with a registry address and a version, like ghcr.io/priya/quickbytesapi:v1.2.0, and push it. From that moment, any machine on Earth with access can pull and run that exact image. Your teammate's laptop, the CI runner, the production cluster. Where should images live? Docker Hub is the public default with official images for everything. GitHub Container Registry sits right next to your code and actions. And the clouds run private registries. ECR on AWS, ACR on Azure. One discipline to adopt today, real version tags. Latest is not a version. Pin exactly what you deploy, so rollbacks are 1 tag away. Let's zoom out and see where Docker fits in a professional pipeline, because this is the picture interviewers want you to have. On your laptop, you develop and test in containers, with Compose running the full stack. In CI, GitHub Actions builds the image, runs the tests inside it, and pushes it to the registry. The registry holds the single source of truth, one immutable image with 1 version tag. And in production, Kubernetes pulls that exact image and runs it at scale, the same bits you tested, byte for byte. Now, about the myth that Kubernetes replaced Docker. What Kubernetes swapped out was Docker's runtime component under the hood, an implementation detail. The things you're learning today, images, Dockerfiles, registries, are precisely how everything gets to Kubernetes in the first place. Docker skills are Kubernetes prerequisites. And now the twist nobody saw coming. AI made Docker skills hotter than ever. Think about what a machine learning workload is: a model, its weights, a specific CUDA version, specific Python libraries, and a serving API. That's a compatibility nightmare, unless it ships as one container image, pulled onto any GPU node. GPU pass-through is a solved problem. Docker run --+all, thanks to NVIDIA's container toolkit. Reproducibility, the curse of ML. It trained differently on my machine. Ends when the training environment is a pinned image. And look at the modern local AI stack. Alma for models, a vector database, an 8N for automation, your agent code. People share entire AI labs as composed files. Every AI engineering job quietly assumes you can containerize a model. After this episode, you can. Before we wrap, the security essentials that separate hobby containers from production ones. 1. Don't run as root. The user directive is one line, and it means a container escape doesn't become a host takeover. 2. Slim, pinned images, Alpine or distroless bases with exact version tags. Less software inside means fewer vulnerabilities to patch. 3. Scan every build. Docker Scout or Trivy in your CI pipeline catches known CVs before deployment automatically. 4. Secrets never go into images. A key baked into a layer is there forever, even if you delete it in a later layer. Use environment variables, secret mounts, or a vault. 5. A Docker ignore file keeps your Git history, env files, and node modules out of the build entirely. And 6. Run read-only where possible. Malware can't modify what it can't write. 6 habits, mostly one-liners. Adopt them from day one. 5 mistakes every Docker beginner makes. Dodge them and you're months ahead. 1. Using latest everywhere. Your build works today and breaks in March when latest silently becomes a new major version. Pin exact tags. 2. Keeping data inside containers. One Docker RM and the database is gone. Volumes for anything you can't afford to lose. 3. The one giant container, app, database, and cache stuffed together. That fights Docker's whole model. Run one process per container and let Compose wire them. 4. Ignoring the build context. Copy. With no Docker ignore file ships your Git history and secrets into image layers permanently. 5. Copy-pasting Compose files you can't explain. It works until it breaks at 3 a.m. Type them out once yourself. Understanding sticks when your fingers do the work. Your 30-day path from 0 to job ready. Days 1 to 10, foundations. Install Docker Desktop and make run, PS, logs, stop, and RM daily muscle memory. Port map, Jinx, and Postgres. Write your first Dockerfile, and make sure images versus containers is crystal clear. Days 11 to 20, real skills. Containerize your own application, not a tutorial app, yours. Optimize the layer order for caching. Pull off a multi-stage build under 100 megabytes. Get hands-on with volumes and networks, and write your first Compose stack with an app and a database. Days 21 to 30, ship it. Push versioned images to GitHub Container Registry. Build images automatically in Actions. Run real stacks like WordPress or Grafana. Add a security scan to CI, and deploy one container to a cloud service. 1 hour a day, that's the whole price. For projects that make Docker knowledge permanent. 1. Containerize your own portfolio or API with a proper multi-stage Dockerfile. Get it under 100 megabytes and put the Dockerfile on GitHub. 2. Build a self-hosted lab, a Compose stack running WordPress, Grafana, or N8N with their databases. It exercises Compose, volumes, and networking, and you end up with genuinely useful tools. 3. A CI image factory, a GitHub action that builds, security scans, and pushes a versioned image on every release. That's the exact workflow companies pay for. 4. My favorite, the local AI stack, Alma, a web UI, and a vector database in one Compose file. You'll learn GPU flags and handling huge images, and walk away with your own private ChatGPT. Build even 2 of these and Docker is yours. And that's Docker, 0 to hero. 3 takeaways to lock in forever. 1. Containers ship the application and its environment together. Works on my machine, is officially dead. 2. The pipeline is Dockerfile to image to registry to run anywhere. That's how the entire industry delivers software today. 3. Kubernetes, CI, and the AI stack all stand on containers. Follow the 30-day plan, and you own the layer beneath them all. Your homework: Docker run Hello World today, then containerize something of your own this week. If this episode brought you value, like it, subscribe to 58 AI Bytes, and hit the bell. Drop a comment. What's the first thing you're containerizing? And catch episode 3 on GitHub if you missed it. See you in the next one, right here on 58 AI Bytes.